Hello, 8th graders. In lesson 9, we're going to be using exponents now to describe large and small numbers using powers of 10. So for an example here, here's the sun, our favorite sun, and it has a mass, meaning on Earth we think of weight a lot, but it has a mass of 2 times 10 to the 30th kilograms. So I would need to move my decimal place here, which is right after the 2. I would need to move it 30 times to the right and add zeros to write out that number with all the zeros. As opposed to a really small number, here's our lovely coronavirus right here. It has a diameter of about 1 times 10 to the negative 9th meters. So I would need to take my decimal, which is right here at 1. I would need to move it this way to make it smaller 9 times and add in those zeros. Now we're talking about the nanometer range there. So in science a lot, we see these really big or really small numbers, and we'll see them written with powers of 10. So here we go. Okay, here's your first column with the values matched up. I just am doing this on a new table. You can draw arrows if you'd like. But one thing I want to talk about again was that negative exponent. So in this first one, 10 to the negative 3 is the same thing as 1 over 10 to the third, which is where I get 1,000. Or 10 to the negative 2 is the same over 1 over 10 squared, which is how we get 1/100th. Okay, in the next few lessons, you're going to be hearing the words that go along with all these place values a lot. So here's your quick review. 1 over 1,000, that's going to be like a milli prefix, like millimeters or milligrams. Here we have a million, a billion. Here's a prefix of centi, like centimeters, because there's 100 centimeters in a meter. And then we have a trillion, and then we have 1,000. Okay, notice we have skipped ahead here to activity 3. This is really meant to be done with cards and a partner, so we're not able to do it that way right now. So we're going to move on and find a blank space where you can draw a table, because we're going to use that to give you some examples here. Okay, the first one we're going to look at is the distance of the sun. It is 150 billion meters from Earth. Now we're going to rewrite this using powers of 10. I notice that my number is really just 150 with 9 zeros at the end, so I'm going to rewrite that as 150 times 10 to the 9th meters. Okay, the next one, the speed of light. It travels at 300 million meters per second, or I could write that over here as 300 times 10 to the 6th meters per second, because it's really 300 with 6 more zeros at the end. Or we could write it another way. We could write it as just 3 times 10 to the 8th meters per second. It all depends on where you think about your decimal being. I could think of it about being right here and then going 8 times and adding those 8 zeros to make my number. So we do need to be flexible in our thinking. These would both be representing the same number here. Okay, the next one, the wavelength of a gamma ray. When you fill this in, there are 11 zeros in between the decimal and your 4 and 8 there. And if I rewrite this, I could write it as 48 times 10 to the negative 13 meters. And that works because if I put my decimal here after the 8, if I move it 13 times to the left, remember that negative exponent is just making it a smaller number, not negative, then I would end up with that decimal in the right spot. Okay, and the next one, the mass of a proton, you have 0 point and then 26 zeros and then 167 kilograms. And if I was going to write that using powers of 10, I could write it as 167 times 10 to the negative 29th kilograms. And that's because if I put my decimal here at the end, I would need to go to the left 29 times to get back to where it is in the expanded version of the number. Okay, to wrap up this lesson, I do want you to find some space where you can write some notes. Just how are we going to go about writing numbers using powers of 10? We're going to split this into how do we do large numbers and how do we do small numbers. Okay, we're going to start with talking about large numbers. The big thing here is that large numbers are going to have positive exponents on them. And when you expand them out, you're going to move the decimal to the right. And that's going to be really important because that'll make your number larger. Okay, so here's an example. If I have 2.5 times 10 to the 6th, then I'm going to write out my 2.5, and to expand this out, I would move my decimal to the right 6 places. So there's 3, 4, 5, 6. I'll write my decimal right there, and then I would fill in all those spaces with zeros, and I would rewrite it nice and clean as 2, and then 5, and then my 5 zeros. And when I put in my commas, I can see that that would be 2,500,000. Let's say I start with an expanded number like 31 million here, and I want to write it with powers of 10. I would put my decimal where I want it to be, like let's say right here. So I want my number to be 3.1 times 10 to the, and I need to figure out how many places it is to the end of the number. And I'll notice here that it would be 7. And so that would be 3.1 times 10 to the 7th. Okay, now how to do this with small numbers. They're going to have negative exponents, and you would move the decimal to the left to expand those out. So for example, if I have 4.3 times 10 to the negative 5th, I would write my 4.3, and then I would move my decimal to the left 5 places. I would put my decimal point there, and then I'd fill in those spots with zeros, and I would rewrite this nice and clean as 0.4043. Okay, let's say I start with a number with lots of zeros and a decimal, and I want to write it with powers of 10. I'm just going to count how many places it is to wherever I want to put my decimal. I'm going to put it right there. And so that would be 1, 2, 3, 4, 5, 6, 7, 8 places. So I'm going to rewrite this as 8.1 times 10 to the negative 8 power. It has to be negative, so that ends up as a really small decimal. Remember that negative exponent does not make it negative, it just makes it really small.